Well, hello there. It's MoNaCo.
And Milks.
Unit 2 Atomic Theory. We're in our second video today. We are going to be talking about, let's see here, we're talking about page 6 and 8 in our pack. We're talking about the subatomic particles, where they reside in the atom, and their properties. Very, very, very critical information in this lecture.
So here we go. Look at this little pictogram on the left. You see arrow is pointing to the black circles with the pluses. Those are protons. Protons are inside the nucleus, have a mass of 1 AMU and a positive charge.
Mr. Milks, what's AMU stand for?
Atomic mass unit.
Okay. Oh, I get it. I remember. It's because they're too small to actually put on a scale. We created the atomic mass unit.
Well, yeah, I mean, I can't even really mass one atom. I can't, let alone one proton.
So we came up with the AMU, atomic mass unit.
You and I came up with that.
Yeah, we're famous.
Yeah.
Yeah.
In our own minds.
To cover that one.
All right, here we go.
The second one, B, that is pointing to that clear sphere in the center there. It's called the neutrons. They're inside the nucleus. They also have a mass of 1 atomic mass unit, but they have no charge. Neutron walks into a bar. He asks the bartender, how much for a drink? The bartender says, for you, no charge.
There you go. No charge. C. C is pointing to that big circle. It's kind of got that plaid texture on it. That is the actual nucleus. This is that dense core of the atom. It has an overall positive charge because of the protons, and it holds all of the nucleons.
So nucleons must be protons and neutrons, right?
You're good at this.
Yeah, I can do this stuff. The next part of the atom are the orbitals. That's the circles. That's where it's pointing to 2 of them. It's where the electrons hang out. They reside. They circle around the nucleus.
And last and not least, E is the electrons. The electrons have a mass of 1 over 1836 AMU. So basically, guys, no mass. It is what we call negligible, and they have a negative charge.
So they do weigh something, but it's really, really, really tiny compared to the others.
Right, but if I ask you which subatomic particle doesn't have mass,
you say electrons.
You say electrons.
Okay, cool. It's like the flies or something.
Right, so basically they have...
It's like 1 hair off the top of my head.
Yeah, not even.
Not going to tip the scales. No mass. Got it. Got it.
There we go.
So let's fill out this chart here. Protons, charge, positive 1, relative mass 1, AMU. Location in the nucleus. There's 2 symbols here. First one's just a plain old P. Second one shows the mass on top, 1, the charge on the bottom, positive 1. How we figure it out, we look at the atomic number of an element.
And we're going to learn what that is. Neutron, charge is 0. Mass, 1 AMU, just like the proton. Again, just like the protons in the nucleus, they are nucleons. 2 symbols, little n, or little n with a 1 and a 0. And the 0 is, of course, no charge.
The charge.
How do I calculate them? I'm going to take the mass number and subtract the atomic number and calculate how many neutrons there are. And we are going to get to this, don't you worry.
Electrons, the opposite of a proton. It is very, very tiny, negligible mass. It is outside the nucleus. It's kind of revolving around it. Their symbols are E negative or E. And we find in neutral atoms that the number of protons equals the number of electrons. In ions, we find the charge by taking the protons minus the electrons. And for neutral atoms, the charge equals 0. Back to our important words at the bottom of this chart.
Nucleons, subatomic particles that reside in the nucleus. That would be the protons and the neutrons.
And the neutral atoms is a net charge. That means overall charge of 0 because the number of protons equals the number of electrons and their charge is opposite. Moving on.
All right, so this is a tile.
Yeah, from the periodic table. Yeah.
Right.
You see like 120 of these on the periodic table.
Right, lots of them.
We're going to
there's
give
a
you the
lot
breakdown.
of hidden information all throughout this.
Yeah,
thing,
this
right?
is like the secret code to understanding how the atoms work.
All right,
So,
upper left-hand corner, this is the atomic mass, the average mass of all the isotopes of an element.
we'll get into what isotopes are in the first place later, but that is where we find the mass of the atoms. The atomic number is the dark bolded number. It's the protons in every atom of the element. It's kind of like the identifying factor.
Seriously, protons are king.
Yeah, they tell you if it's got 6 protons, it's got to be carbon, period. End of story. If it's got 7, it's not carbon, it's something else.
Yep. All right, the little numbers with the dashes underneath that is the electron configuration. This is the number of electrons in each energy level. If I add them up, I get to the total number of electrons. Notice 2 plus 4 equals 6, so that neutral atom would have 6 electrons.
This is not 2 minus 4. This is 2, then 4. It's a dash. It's a sequence. It's like an order of operations there.
Yep.
It's not 2 minus 4. It's 2, then 4. Moving on. Element symbol. These are the things that most of us are familiar with when we're talking about elements. It's the letter we use to talk about a particular element. Gold is AU, silver is AG, carbon is C, nitrogen's N, etc. Those usually come from the names of the elements, the first letter usually, and sometimes the second.
And sometimes they're in Latin.
Yeah, or they're old ancient
Isn't there
Greek.
a rule, too, about these?
Yeah, I think we're going to get to that later, though.
All right, fair enough. All right. Last but not least, oxidation numbers. These are the possible charges on an ion of an element.
Yeah,
Not an
little
atom,
typo.
these are an ion.
Fix
so you
that.
can see that carbons could have a -4, a +2, or a +4. We will get into that even later.
Yeah, fix that in your notes. Possible charges in an ion.
Wow,
of an
extra
element.
points. Look at
Extra
you.
points, give them away. Average atomic mass. Here's our definition. Average mass is all the naturally occurring isotopes of an element. What do you mean naturally occurring, Mr. Mellis?
Well, naturally occurring. They happen naturally.
Oh, so not like in like research laboratories and nuclear reactors and stuff?
Well, yeah. I mean, if I start slamming, these things around, I can make all sorts of things.
New elements, right?
Yeah, these
But
are
we're
just
not going to talk about
No.
those ones. This is the natural ones that are here on the Earths before we chemists started messing with things.
Right. Yeah.
Got it.
Atomic number. The number of protons in every atom. Remember, protons are king.
Yep, protons, very important. Atomic number, protons are synonym. Electron configuration, like I said before, it's the number of electrons in each energy level. It's like a sequence. You add all of them up to get the total number of electrons, and if you look at it as a sequence, it's kind of a roadmap as to where they're hanging out around the outside of
Where
the
they
nucleus.
reside, even.
Yep, reside, hanging out, reside, you know.
Selected oxidation states, the possible charges an ion of an element could have.
Yeah, so like pluses or minus, if it can lose or gain electrons, it gets to one of those states, and we'll get into more details on that when it's important later on. And the symbol, this is what I said we were getting to later, it's the letters used to identify an element. First letter is always capitalized. Second letter is always lowercase, and I think some of those come from ancient Greek or Latin.
Yeah, a lot of them.
So we don't even, ferrum.
Ferrous.
Ferrum, that was the Greek, that's what they used to call it. They knew
Right.
about it back then, so they
That's
kept
why
the
it's
F.
symbols F-E and not I.
It's like a heritage thing. It's like giving props to your ancestors. Most information, we're talking about 3 types of notations here. First one is the atomic symbol notation. It has the mass, the symbol, and the number of protons in it.
Yeah, we'll probably be using this one the most, right? Because it has everything in it.
Yep.
But then there's a simpler one. It's got carbon 12. It's going to have its name and its mass.
Full name and the mass.
Yeah, it's spelled out.
Now here's the simplest condensed type. It's C12. Symbol and mass. All 3 of these things are the same. We're talking as chemists about the same element, but there's 3 different ways to draw it. Okay, so you got to be familiar with all 3 because you will be seeing all 3 throughout the course this year.
We're kind of geeks. We like the most information, so we're going to be looking for that one the most.
Now the mass number is the number of protons plus the number of neutrons. So you do a little addition to figure out the mass of an atom.
True. I mean, they both have mass, right?
They
Protons,
both have
neutrons.
one AMU apiece, right?
There you go.
So you add them together. Why do we ignore the electrons?
Because they have negligible mass.
They're like crumbs on the bed sheets. It doesn't. They're tiny. Protons, atomic number. It's the same as the atomic number.
To do neutrons, I take that mass number, which is the total mass, and subtract the protons.
Yep. The nuclear charge is the atomic number because proton's the only nucleon with a charge. Okay.
Good.
So there are only 3 subatomic particles. You have to know everything about these 3 subatomic particles. Locations, masses, and charges are critical. So if you're not understanding it at this point, go ahead, YouTube, internet, Google image, search proton, neutron, electron. Find the color-coded pictures and just, memorize it. You have to know these things.
Absolutely. Inside, outside, forwards, backwards, the whole 9 yards.
Upside down even.
Come on.
Oh.
See you guys tomorrow.
Yeah.